Okay, number 52 is exactly the same as number 17, except they gave us different values of capacitors this time. So the little hint that they gave us was that the voltage across C3 is 40 volts, and they want us to find the voltage across everybody else, and also from A to B. So if we start with the extra hint they give us, V3 is 40 volts. That's from this side to this side. So if we follow those wires around, everything on the same wire is at the same potential. So that means from across C1 to the other side of C2 is also 40 volts because they're in parallel. So a good place to start is combining C1 and C2. So let's see what that gives us. So these are in series with each other because they're just in a straight line. So that's where we use our reciprocal addition. So equivalent 1, 2 is equal to 1 over C1 plus 1 over C2. So C1, they told us, was 6 microfarads, and C2 is 3 microfarads. So we want to get a common denominator here so we can add them together. So let's multiply that 1 by 2. So that's going to give us 1, 2, 3 over 6 microfarads, or 1 over 2 microfarads. So flippy floppy, C12 is 2 microfarads. Okay, so that means we took this guy and made him look like this. Blam. C12. Okay, so C12 has a voltage across it of 40 volts. So V12 equals 40 volts, because that one did. So we can Q equals CV this guy to find a charge across those. So C is 2 times 10 to the minus 6 farads. V is 40 volts. 2 times 40 is 80 microcoulombs. So now we can stretch this dude back out. Because these guys are in series, they have the same charge across them. The charge from one side to the other is the same as the charge from here to here and here to here. Because we want our electric field to cancel out in between. So this plate has to have equal but opposite of this plate. I'll explain this a little bit more in 17. Okay, so that means Q12 equals Q1 equals, that is not a Q, that is an 8, equals Q2, which is 80 microcoulombs. Sweet. So voltage 1 is Q over C, and Q is 80 microcoulombs, C is 6 microfarads. Oh my god, I can't write today. Microfarads. That is an F. Our micros cancel out. So 80 over 6 is 13.333333 volts. Now we could do the same thing for 2, but I'm lazy. So we know that the whole thing is 40 and across 1 is that. So I'm just going to take the difference. So this is V1. V2 is 40 volts minus 13.33333, which is 26.666666666 volts. Alright, so that's 1 and 2 down. Blam. Okay, so now we want to figure out the voltage drop across here, but since we don't know A to B, we're going to have to find our equivalent dude to get our charges again. So now we want to combine 1, 2, and 3. So 1 and 2 combined was 80 microcoulombs. That made it look like that. So now these two are in parallel, so I just add them together. So C123 is C12 plus C3, which was 2 microfarads plus 4 microfarads, so 6 microfarads. The voltage across this whole thing is 40. So Q 1, 2, 3 equals C 1, 2, 3 times V. So 6 microfarads times 40 volts. 6 times 40 is 240 microcoulombs. Okay. So now my circuit looks like this. So this is C1, 2, 3. This is C4. C1, 2, 3 and C4 are in series, so they have the same charge. So C1, 2, 3 has a charge of 240. So that means so does 4 microcoulombs. So now we can stuff in for V. V equals Q over C. So 240 microcoulombs. C4 was 8 microfarads. My micros cancel out, and I get 30 volts. Okay, so the voltage across here is 30. The voltage across here is 40. So the voltage from point A to point B is the sum of those, because they're in series. So VAB equals 40 volts plus 30 volts, so 70 volts. And that's it.